So I'm going to talk about blockchain. A lot of people don't even know what it is. And so I'm going to start basically assuming that you don't know anything about it, other than you've read the name and you're kind of not sure whether you should know something about it or not, or whether it's just really stupid. And some people think so. And so I'm going to start assuming that. Now, there may well be people in the room, I would kind of hope so almost actually, who know more about it than I do. And that would be really cool. And so if you want to say something, please do, while I'm talking or afterwards. Okay, so I'm going to talk about the blockchain. Last year here, I talked about Bitcoin actually. And blockchain is actually related to that, but it's different. And I'll end up talking about Bitcoin a little bit because it's hard to talk about the blockchain and understand it without understanding Bitcoin. So this is Richard Branson, obviously. And so he's saying blockchain is an economic revolution. It's going to change everything. He invites a group of people, actually, they're really lucky people, out to Necker Island, which is in the British Virgin Islands, and they hang out for a week in the summer and talk about blockchain and how it's going to change the world. So he's definitely big into it. On the other hand, Craig Perron has just written a blog where he says, oh, it's just really, it's overblown. There's people who are starting a firm where they think they're going to settle swaps on the blockchain, and it's just not very sensible at all. And so his quote is much longer, and it's pretty easy to agree with. Techno-utopianism makes me extremely skeptical. I mean, it is the case. You read some of this stuff, and it's like totally ethereal. It's like, I can't get my hands on it. I don't know what it is they're really talking about. I'm going to try to make it all concrete. That helps me understand things a lot. And part of what we'll look at is as well is this really just all pie in the sky. You know, that there's really nothing to it. People are going to collect a lot of money from venture capitalists, and then they're going to go home rich, and nobody gets anything. And there's some, I'm trying to see if I can use this. I guess not. No, this way. And there's some tendency for things to be this way. This is the behavior of the price of Bitcoin, the price index since 2013. Bitcoin actually started out trading for a nickel per Bitcoin, and now it trades for about $650 US dollars. So that's a huge price increase. You know, some people have gotten pretty wealthy doing that actually. And so this kind of actually colors it, I think, actually. Because a lot of people are very skeptical about Bitcoin, whether it's ever going to be used for much of anything, and whether it really even makes very much sense, and it's actually pretty complicated to try to understand, on top of not making much sense when you do understand it. I don't agree with that solution, but I just mean some people do. And so the blockchain can easily get colored by that. But it's inevitably related. Whoops, wrong way. There we go. On the other hand, I'm going to suggest, look, don't be too skeptical. This is Ken Olson. Whoops, I'm going to have trouble with this now all of a sudden. It's too sensitive. Ken Olson was president of DEC. They were makers of computers. They were like the best computers for small operations that you could get, called mini computers back in the 70s. And he said he couldn't see any reason why anyone would want a computer in their house. The poor benighted souls who might want one. This is a Cray supercomputer in 1979. All right? You can tell how big it is by the seats around it. And it's way taller than that. And these things had to be in super cooled rooms because they got so hot. And so you'd have to really have big air conditioners to keep the thing cool enough to continue operating because of the number of processors and everything else. This is a computer today. You don't really think of it as a computer, but the fact of the matter is with the Google operating system, you could actually program it to run regressions and do all kinds of stuff if you wanted to. You'd be kind of crazy if you did, but you could. And it's 15 times faster than a supercomputer. And so not only do we have supercomputers in our houses, oh no, we have them in our pocket too, and we wander around, you know, and we watch all these people sitting at dinner, just, you know, both of them on Facebook, doing whatever, instead of talking to each other. And so these computers, so you don't want to be too skeptical in the sense that it's easy to say, oh, that's not really feasible. You can't really be sure what's feasible 20 years from now. It could be very different. I mean, because some of the issues that actually arise concerning the blockchain are just throughput questions. How much can you do in a certain period of time? The speed of light is inevitably a binding constraint as far as we know, all right? But computers could be a lot faster. People are working on something called quantum computers, which actually would be orders of magnitudes faster than the digital computers we use today. You know, so throughput's not necessarily a binding constraint forever. You don't really want to look at the technology available today and say, well, we can't do it today, so we're never going to be able to do it. It's like, that's not true at all. So it doesn't pay to be too skeptical. I just find this remarkable, you know. I'm actually old enough with the gray hair and everything. I remember supercomputers. We didn't have one. We had a computer where the person I knew at the computer center got excited when she got 384K in her Amdahl computer, which was a super IBM computer. All right. Now, of course, like I've got 32 gigabytes on my personal computer. I got more memory than they had on their mainframe computer in my pocket. And so all of these things change over time. So you don't want to think about it being too technologically limited. There is a huge amount of press about all of this, though. This is just a sampling from the last few days. It's from September 29th to October 7th. UBS is going to build a blockchain-based trade finance system. JP Morgan has a new twist on blockchain. And there's a speech by a governor of the Board of Governors talking about using blockchain for clearing and settlement and what might or might not be able to be done. And so the Board of Governors is studying it. So this is a big deal in the sense a lot of people are involved in it. Now that doesn't mean that Craig is wrong. That is that it's just really, it's all hype. And it's really not going to come to very much of anything. So what I'm going to talk about is, so what is the blockchain? This is a little bit more in terms of surveys of financial firms recently. This is IBM surveyed banks, and 15% of them said they'll have something by the end of next year. I was actually at a reception in Greenville, South Carolina, because I'm at Clemson. I was in Greenville, South Carolina, and this reception, and actually there was a banker there. And this banker, a relatively small bank, not like Nations Bank or something like that, they were planning to have a blockchain-based implementation of something, I'm not really sure what, in the next year or so. So there's lots of people talking about this all over the place, even in, like I say, in Greenville. 65% of the banks expect to have some solution in production in 3 years. It does start to sound like hype, doesn't it? 14% of the financial market institutions expect to have blockchain solutions in 2017. All right, that's next year. So apparently this is at least somewhat important. Oops, hopefully that'll go away. I don't know. Oops.
It's gonna escape.
I gotta get the other side. Escape gate. Because I'm backwards on it. I think that'll be good. Right? Yep. Sorry. I should have brought my little thing. So what are they going to use it for? Clearing and settlement, wholesale payments, equity and debt issuance, and reference data. What does reference data mean? Reference data means things like contracts. That is creating a record of exactly what, I think I interpret it as for creating a record of exactly what the contract was. So what is a blockchain? It can actually mean different things. Another term that people are using for it, maybe because of the hype about blockchain, is distributed ledger technology. It actually has a clear meaning in the context of Bitcoin, and it has a clear meaning in the context of other applications. A lot of the other applications are proprietary, so people don't tell you about them. So you're not really quite sure exactly what they're doing in the details because they don't necessarily want to tell people who are not in the particular consortium that's operating. So I'm going to talk about Bitcoin first. The nice thing about Bitcoin too is it works. And so it's functional. You know, it's actually the case that the blockchain was the major innovation that makes Bitcoin work. It's the big difference between Bitcoin and all the electronic money before it. And so it is a big innovation in that sense, all right? And it does make it work. And so it's a functioning technology. And so it's useful to see in that context, and then the question is how can you generalize it to other things? The key elements are, it's a database of transactions. In a sense, that's trivial. It's just a database. You know, it's like something you might have on your computer, actually. So it's a database. But then it's different, all right? It's a peer-to-peer network, which people use the word distributed as a synonym for. Maybe it sounds less geeky. I'm not sure. Peer-to-peer network is actually pretty clear once you see the picture anyway. That's a really big difference. Blocks are added to the blockchain. That just means that the list of transactions grows over time. Okay, that's not such a big deal by itself. But to reach consensus on the current valid transactions. The key thing that's really different about blockchain on Bitcoin is it's peer-to-peer. That's what creates issues. This is a client-server network. This is sort of like what your university has, or if you're a firm, that's what they have. There's some central server, and you rely on the central server for applications in a lot of cases, for databases for sure, for access, for example, at Clemson, access to CRISP is through the central server. All of this stuff you rely on there. All right, so that's a client-server model. That's pretty much the standard setup. But a different setup is peer-to-peer. Peer-to-peer is there's no server. Everybody has the same standing. My computer is just as trustworthy or untrustworthy as Benton's and anybody else's, all of yours. They're all hooked together, all right? Now remember, there's this database that's sitting there behind there. Wait. See, a database in the context of a client-server network is easy to think about. You have a central server, they keep track of everything, and that's where you trust the data. So when I want data from CRISP, I go to the mainframe. I don't know that you have a mainframe, but I go to the server. And I get the data through the university, from a central place. And that's where other people get it too. I don't get it off somebody else's computer. Maybe they've screwed it up in the meantime, you know, or substituted something that they find more interesting. Or the file's even named wrong. Peer-to-peer network, we got those issues. Mm-hmm.
May I ask a question?
Of course, please do.
So in this diagram, some of the nodes are not connected directly to other nodes.
Right, they're not necessarily connected to each other. That's right, that's on purpose.
Okay.
Right, that everybody's not necessarily connected to everybody else. It's like when I go up on Bitcoin and I actually have a copy of the database on my home computer. I connect to 8 computers, 8 other computers. And I think that's a setting in the wallet that it looks for 8 other computers, and after that it really doesn't try very hard. But there's lots of other computers in the network, and so it's definitely the case that they're not all connected to each other. You're connected to some, not connected to others, and this is changing over time. You turn off your computer, you're not connected to other people. You turn it back on, you're going to be connected, not necessarily the same people you were before. So this is a very dynamic kind of network. So you can see, if you have a database that you're trying to keep track of, this is kind of a problem. In addition, why would anybody maintain a copy of the database? That is, why do I have a database on my computer? Well, it's for entertainment value, to be perfectly honest. And probably some other people too. You know, and I'm going to try to do some research based on it, so that's one reason for keeping a copy of it. But that's not maintaining a copy, and I'm not adding transactions to the database at all. All right, the people who do that, I'm going to introduce the term now. There's a few terms I'll have to introduce. One of them is people who add transactions to the Bitcoin database are called miners. The idea clearly of the guys who invented all of this was, it was like mining for gold. It takes some effort, right? But they call them miners, and I'm going to use the word once in a while. So miners are the guys who add transactions to the database. And there must be a payoff to them. The issue is, how do you get consensus? Consensus in computer science stuff, apparently, from what I can tell, is agreement on the state. All right. In this context, what it means is it means agreement about what transactions are in the database and what transactions And you have these computers that are connected in this peer-to-peer network, not necessarily connected to each other, and they all have to agree on what transactions are actually, they've happened and what transactions have not happened. So this is a complicated problem. And actually, Bitcoin solves it, like I said, for sure. Another technical thing I'm going to introduce besides calling people miners is something called a hash. It just comes up. I'm not going to talk about public key cryptography. I'm not sure I'm the right person to do that, but even if I did, it would take a while and then you'd probably go to sleep and it'd be boring anyway. And it's complicated. It's not too complicated, actually. It's just, it's a certain amount of math. You get to read a number theory book and then it all makes sense. So they involve hashes of records. And the hashing function reduces a message of some length to a shorter output. All right, so that just says take a message, you put it through the function, and you get some output, and it's shorter than the input. Other characteristics are actually very important to this function. It's highly nonlinear. So if I change one letter or one byte, it can drastically change the output. Moreover, it changes the output in an unpredictable way. That is, I can't predict what the change is going to be. You know, if I change the letter A to the letter B, it could change every single symbol in the whole output, in the entire sequence. And it's not invertible. That is, if you tell me what the hash is, I can't tell you what the message is, even if they're of the same length. And so this is used in cryptography, these versions of these functions. Whoops, wrong way. So the basic elements of blockchain, it's a database, remember, is there's a header for each block. That is, it's a chain of blocks, all right? So what we have is we have a sequence of blocks, and each block has a header. And the header has the address of the miner receiving transactions fees, and they get some new Bitcoins right now too. Okay? The hash of the previous block. That's why it's called a chain, because it's got the hash of the previous block, not blocks two before. So it's a sequence, and you can't just move things around in the sequence arbitrarily. And this is very important, actually, for the integrity of Bitcoin. Not that we're going to go into the details of it, but it is really, really important. There's a timestamp, so you know when it was. Something called the target difficulty level for the hash of this block, which I'll explain in a second. And then an open field that helps you with this difficulty level. So a block includes transactions. And this is really pretty simple. Actually, it's what you'd expect if you thought about it for a minute. You have to know who's going to get the Bitcoins. So they have an address. All right, it's a computer set of numbers, but it's an address. Tells you who's going to get it. You have to know who's going to send it. This is where cryptography comes in. A digital signature of the part, it's not the only place, but one place. Digital party sending the Bitcoins. Digital signature of the party sending the Bitcoins. And then how many Bitcoins you're going to send. So that's pretty obvious for a transaction. Who you're going to send it to, who's going to send it, and how much you're going to send. Okay. You know, that's not particularly mysterious at all. It's actually more complicated because of the digital signature and all of that stuff. But the basics of it's pretty straightforward. That you have a header, and then you have a bunch of sequence of transactions. Now there's a limit to the size of each block and some other things. There are details, obviously. But the fact remains it's all pretty simple in terms of its structure. But what we've got to worry about is how do we decide that a transaction, that a block is included? We've got this peer-to-peer network. And so suppose I add a block, you add a block, and they're different blocks. Who's got the right set of transactions? And worse, okay, so he adds one, then he adds another one. You know, and you add one to mine. And so what's the right one? How are we going to decide? How are we going to reach what's called consensus, agreement on the state? All right? These miners are the guys who actually add blocks. What they do is they actually solve, through a hashing function, a numerical problem where they're trying to what they're trying to do is run the header to the block through a function, and then they're trying to get an output that's less than or equal to some value. All right, so they have to get a small value coming out of the function. The smaller the value is, then the lower the probability that you will get that result, and so the more difficult it is. It's not more difficult in the sense you have to think about it, because the only way you can really search efficiently for this problem is to randomly search across the space. What you do is you add arbitrary numbers called to this nonce, and that does it for you. This function is hard to solve in the sense it's hard to get this solution, but once you do have it, it's easy to verify that it's correct. That is, it's not the case that this hashing function takes a long time to execute. It doesn't take very long to execute at all. The thing that makes it hard for the miners is they can't take an arbitrary output. They're looking for an output less than or equal to some specific value. And so whoever first solves this problem gets to add the new block. Now, why do they want to do that? Because they get the new bitcoins that are created, and they get the transactions fees. That is, everybody whose transaction is included has a fee to cover the transactions cost. And so the miner gets that, and then they add it. So how does this produce consensus? The rule is the longest chain is the correct one. All right? It's a system. And obviously, if somebody did something different, then things would be different, but then they wouldn't be part of the system and people wouldn't recognize them as being part of the system. The rule is the longest chain is the correct one. And so if my chain is longer than your chain, then mine is correct. Now, on the other hand, if mine's the same length as his chain, but different, then somebody's going to add a block to my chain, and it might make it longer before his. And then mine will be the correct one. And this actually happens during the course of a day even. Mm-hmm.
Can that be manipulated? Can you make your delivery longer? That's how it works.
I'm sorry, what?
Can you make your chain longer? Can you deliberately make it longer so that it's longer than mine or somebody else's?
No, because I have to solve this.
Manipulate
I can't add without solving this numerical. I can't add a block without solving this numerical problem. I cannot predict that I will be the first one to solve it. People actually form pools to solve this because it's actually the way it's all working right now. If you tried to on your own computer, if I tried to mine on my own computer and didn't do it with anybody else, the expected time to my being able to add a block is like 450 years. It's virtually, And what people do is they combine together. And so I search part of the space, you search part of the space, he searches part of the space, and then one of us will hit it, and then we divide the winnings. So we basically pool our efforts. Whoops, did it again. No, it won't, will it? There it is. Whoops. And so I can't just add them arbitrarily. I don't want to go too much into the mining problem and sort of how it all works and everything else, but I want to give you the general idea is the thing that's producing consensus is this rule combined with having to solve this problem, and then these miners do it. And then, empirical proof, and this proof is not the best word, empirical validation is it works. All right, so there's more details and everything. If you think of, well, what about this? What about that? Yes, there is what abouts, as a matter of fact. But there are answers to those questions. And so this thing works in the sense that it solves this problem of adding blocks with no central server and reaching consensus about what the current state is. It's very important that there's a rule that decides and that everybody agrees on what the rule is. This is actually an example.
How do the miners find out about the transaction, and how do they know if the transaction?
They're broadcast on the network.
So every transaction just goes out to everyone, and the miner gets it.
You probably wouldn't get all of them. You'll get a different set of transactions than I will, for example. And then we keep them in what's called a store in our main memory, actually. And then, so you'll get them over time if we're connected to different computers, but presumably there's overlap somewhere, so it's not a complete partition. Then eventually will converge to having the same transactions, although you might have included some in the block, and maybe you won, so they're included, and I didn't, and then I have to include them in a block because I copy them from yours. And so there's a lot of memory issues. Unvalidated transactions have to be synchronized.
How do you measure the length of a blockchain? So in other words,
By the number of blocks.
by the number of blocks. So if I say, I've got 15 blocks, let's suppose the last block height was 14, and I think I found 15, and I say, I've got 15, and then he says he's got block 15. How do we know which is the right block 15?
Earliest timestamp, right?
Basically, it'll probably get resolved by the next block. That is, if you're not communicating with him directly, see, if you're communicating with him directly, if you find it first, then he'll know that you found it. He doesn't know how long it's going to take him to find it. It's not like you can just keep on, oh, I'm so close, I know I can do it in the next 15 seconds. No, it can take you another 10 minutes. The expected time is probably 5 minutes, assuming you have a big enough pool and other things to make the whole thing work. On an individual computer, like I told you, it's hundreds of years.
Is it correct to think of a blockchain as denominated in bitcoins?
Denominated. Well, basically what it does is it keeps track of trades of bitcoins. So I wouldn't think of it as denominated in bitcoins. It's basically a series of transactions. It's like a ledger. I mean, I actually think of it in part as it's like I have Excel spreadsheets that I do for every month for my checking account. And I keep track of all the inflows and all the outflows, and at the end of the month I get so much, and then I go to the next month. And that's kind of like a block, in the sense it's got a bunch of transactions, and then I add a new block when I get to a new month. I wouldn't necessarily have to, I mean, people didn't used to, but it's
But
convenient
that's
to me.
denominated in dollars.
Yes. Oh,
What is
okay,
this
the transactions are trades of bitcoins. They're not denominated in, it's like half a Bitcoin. All right, so it's not like it's denominated in US dollars. It's like, what's the price? The price is not included, actually. You might find that interesting. It wasn't obvious because I didn't mention it, but the price is not included. So you don't know what currency it was traded for, or whether it was traded with Overstock.com for a book or whatever.
So in order to make sure that a particular coin has not been double spent, the miners have to verify that, indeed that digital signature is valid for that particular address.
And that it hasn't already been spent.
Right. Now, does that mean they have to go through every single block from the beginning of time, or is there an index in each block of the unspent coins?
Yeah. My understanding is no, they don't. That it's indexed, and so it's like a lot of databases in the sense it's indexed, and so it's indexed differently. I think it's something called a Merkle tree is actually part of what's going on. In part, you're getting further into the coding of it that I'm familiar with. But they don't have to go through them all. It's not like it, because that would take quite a while.
I think they actually do go through all of them, but they do leverage the Merkle tree, so it makes it a little bit more efficient. So at every block, you can trace it back to the Genesis block at the very beginning of the block.
Right. Yeah. Well, there's a sense in which you have to go back all the way, in the sense that, suppose that, I did, not the Genesis block, because that's Nakamoto, but suppose I did a trade in some early block, and then I've just sat on it since then, and I sold it. Well, if you're going to find out that I sold it, you have to go back. And if you don't go back, but it's done efficiently, so it actually doesn't, it's not like it takes a supercomputer today to solve the problem. There's a lot of sophisticated computer science stuff that goes into this programming. And so you keep the longest chain of the transactions, and basically it results in what a book calls eventual convergence. That is, there's no guarantee that everybody agrees right now at this particular moment, and they probably don't. And every day there are actually people add blocks, and then have to take them back.
Yeah, I have a question regarding you sold out Bitcoin. What do you receive when you sell?
Wait a second. I hear it sometimes.
When you sell a Bitcoin, what do you receive, for example?
When you sell a Bitcoin, you see.
Oh, okay, yeah, no, I get it. Whatever you want,
What did you receive?
whatever you want. You can trade Bitcoin for dollars, you can trade Bitcoin for Australian dollars, you can trade Bitcoin for books, you can buy a cup of coffee with Bitcoin. You can, anything, if somebody will take your Bitcoin in exchange for something, that's what you can use it for. And if
Yeah.
they won't take it, then you can't.
Yeah, the blockchain is a payment system, not an exchange system. So this is a way you would make a payment. Whatever exchange you're getting for that is secondary. Or
Right, it's not included in this. It's a record of ownership of Bitcoins, not a record of ownership of US dollars or what's been traded. You know, people often don't realize this. There's no prices. And so if you want to know the prices of these trade for, you don't know from this.
Sorry, this is a very basic idea. I'm just trying to learn. So each Bitcoin is tracked, it has its own ID, so you can track what happened.
Each person has one or more addresses.
Each Bitcoin.
Each person. And so if I buy a Bitcoin from somebody, then it's a transfer from your address to my address. All
But
right?
if I have 5 Bitcoins, how do you know which one is transferred?
You're sort of asking whether it's path dependent. Like if you're the 9th person to hold a Bitcoin, does anyone know without going back on the envelope or whatever? You know, do they know who the other 8 people are, or is that now irrelevant?
Sometimes you can figure it out, and sometimes not.
It doesn't
Computer
matter.
scientists have actually written papers trying to do this because they want to understand the transaction structure and what's going on and everything else. You know, so what they do is they end up creating rules of thumb to try to go back. Because there's no, if I have 5 Bitcoins, then one of them might be from here, that person, this person, this person, this person. It doesn't matter which Bitcoin I give to them.
Okay, you get the quantity,
It's
but
the
you don't know
address.
which one you
Yeah,
get as the
the
ID.
Bitcoin themselves do not have addresses. They don't have serial numbers like a dollar bill. But people, I don't want to say people, but they go to and from.
right, but the
And I can
addresses,
have multiple addresses, actually.
right, the addresses are best used as single-use numbers because you don't really want to be using the same address for everything. Think of it as a serial number of a coin, but each time you run it through it, it'll come out with a new serial number.
Okay,
So it's a person-based address.
Yep.
You don't need that to understand the blockchain. No.
Right.
That's,
So the
that's just a
address is
Bitcoin
unique
feature.
to each
Right.
transaction? Is the address is unique to the transaction, and it keeps changing, even for the same Bitcoin, when you have another transaction, you have to use a different address?
Yeah, it's not
Different
like you
people have
have
different
one.
addresses.
Yeah. It's not like you'll want one immutable address forever.
No, that's true too. So
Yeah.
you can have multiple addresses for
Yeah.
one person, all right? But you can't transfer a Bitcoin without transferring from an address that it was previously transferred to. That is, it's a chain of transactions in the sense that, see, the thing is I don't have to trade just a Bitcoin. I can trade half a Bitcoin, a tenth of a Bitcoin, or 5 Bitcoins.
Well, when the universe was first created, who created the first Bitcoin?
Satoshi Nakamoto. It's true. It's a Genesis block, is what it's called.
Which is a fake,
One of
which is a
the
fake
many dumb
name.
questions. Bitcoin is the term that's been used, was initially used. But we've got Ethereum, we've got all of this various
Sure.
stuff going on out there. Is Bitcoin going to be the permanent term that's going to be used?
Bitcoin is a term for a particular currency. And so Ethereum has its own currency. It has a different blockchain and it has a different currency.
But it's built
There are
on-
other coins called like Litecoin. There's like hundreds by now, actually, I think. Most
So
of
these
them are
are
relevant.
all terms for the process. And so,
No, Bitcoin,
I think cryptocurrency
Bitcoin-
is what he's looking for.
yeah, cryptocurrency is a term for the general thing. Yes. Thank you.
So
So in the transaction of Bitcoin, everyone needs to have your real name, right? A real name, your address.
Oh, no, not your real name. No. Your address is actually a sequence of characters.
But what I mean is that possible myself serve as the market maker that I trade between the same? One real one and one virtual one.
One real one and one virtual one.
Yeah, I
Most
created.
people call this stuff virtual already.
Okay. Yeah, I created like a fake person, fake account, and a fake.
Well, you don't need a fake account. You can have one account, you can have multiple addresses. You can have quite a few.
So will I create any?
And it's all public key cryptography. Yeah, I don't want to get too far into this, but, because otherwise we won't get to the blockchain stuff, is that, what was I going to say? Brain freeze. What was your question? I just, because I know we got to get going.
Create a fake account and
Oh,
fake
okay,
person
yeah.
and have like
Yeah,
transaction account of market.
Yeah, Bitcoin is what's called pseudo-anonymous, all right? It's not literally anonymous. Because if you can, people have public keys and private keys. That gets into the cryptography only a little bit. Then the address is related to the public key. And the thing is that if somebody knows that my public key is this particular number, then they know everything I do through that address. They know it's me. Now, on the other hand, what they really know almost always is nothing more than an address. And you can't infer who it is. Actually, there was a paper, this is kind of funny actually. Yes, there's a couple of computer scientists in Israel. What they did was, among other people, they tracked through the whole blockchain and they were sorting out, trying to sort out who's doing what, how much people are spending and everything else. And what these computer scientists did was they said, we know who the dread pirate Roberts is. We figured it out, is what they said. They wrote this little paper. A couple of days later, this guy said, look, that's my address. That's me. I'm not the dread pirate Roberts. I've never bought drugs on the internet. I don't sell drugs on the internet or trade. I'll let other people do it. And so they got it all wrong. And so you're kind of anonymous, but the actual transactions you're engaging in are not anonymous. This is actually kind of important for the blockchain if you think about it, for financial transactions. That is, I don't know whether it was Goldman Sachs or JP Morgan who just bought 10,000 shares of IBM, but I know one of them did. That would be a lot of information, right? And so on the blockchain, if somebody buys 10 Bitcoins or 10,000 Bitcoins, which would be huge, it's recorded. Now they can try to obscure it by using multiple addresses. Think about what people do in financial markets when they want to do a big trade and they can't do it any other way. Is you break it up across brokerage houses, you break it up across accounts, you break it up across time. You try to fake the whole thing so that other people don't realize what you're doing. But that's an issue with the blockchain, if you think about using it for other things. Which one do I go?
Just hit M on the keyboard.
Yeah, no, I know, I can use the keyboard. Whoops.
There you go.
Yeah.
Just hit escape.
Yeah. Thanks. This consensus problem is an example of a general problem in computer science. Leslie Laporte, who created LaTeX actually, you might know his name from there, actually is pretty famous computer science in general terms. And he talked about what he called the Byzantine generals problem, which Bitcoin is trying to solve, and anything with a network like we're talking about is trying to solve. His idea is so you have a bunch of Byzantine generals that are circling a city. They're trying to decide whether or not to attack. They're all generals, all right? So it's not like there's some super general who's going to tell them what to do. So what they want to know is everybody else going to attack? If everybody else is going to attack, I'm going to attack. If other people aren't going to attack, well, I sure don't want to because I'll get slaughtered. And so how do I solve this problem? And that's what this Byzantine generals problem is. Part of the reason I have to mention this is because when we think about
Oops, where did I-
When we think about trying to do this in other contexts, the way it's solved in Bitcoin is not necessarily the most useful way to reach consensus. And in fact, it probably isn't. There's serious, there are things that at least bother me. But on the other hand, we have to have a way of solving it, and the name actually uses Byzantine generals, so it's hard to avoid. If we think about trying to generalize it, what is it we're trying to generalize? The clear thing is, it's a record of transactions. All right? It happens to be in Bitcoins for Bitcoin, but it's just a record of transactions. It's a record of trades. And it actually establishes ownership. Now, the way it does it in terms of Bitcoin is through these addresses, all right? And so it gets into cryptography issues in terms of relating it to other things. But basically, it's really no different, in a way, than like in Greenville, South Carolina, they have a record online now, going back, I think, to 1984, of all the property transactions in the county. And so you can look at who bought the property, who sold it to whom, who sold it to who else, and that transaction record is sitting out there. Now, it's maintained by the county, right? So I can't just say, well, I think I just bought this property, so I'll just transfer it to me, because I think that would be fun. I don't get to do anything to it. It's all very central. So you have this server and then all the other ones. Basically, the idea of blockchain is to solve it and not have complete trust in a central server. Because that's what you're doing. You're assuming that the county auditor, or whatever this title is, has the correct record. And then you access that record to find out what's going on. I don't access my son's record to find out what's going on. Computer to find out what's going on. Or just a random person's, even. So if we think about financial markets and what we might be able to do there, you know, banks do lots of transfers, interbank and other ways. Financial markets, obviously, there's lots of huge numbers of trades. There's a question of who owns what. All of these are potential applications. Now, that doesn't necessarily mean they'd be useful. You might think, well, they wouldn't really be useful, actually. Yeah, maybe the mouse will go away. There are other possibilities, like property registries, something called smart contracts, which I'll talk about just a little bit, and autonomous distributed organizations. And this is probably where Craig gets a little skeptical, actually, is because people actually talk about autonomous distributed corporations. Basically, a computer program is a corporation. Really? Sounds kind of weird. Maybe pie in the sky, even. So there's actually been a trial recently that is pretty well documented, everything considered, in terms of what's proprietary and what's not proprietary, by the Japan Exchange Group, where basically what they did was they looked at settlement of stock trades. That's the issue they looked at most directly, that I found most impressive. And they looked at the issues that arose and what seemed feasible with current technology and what seemed infeasible with current technology. And they were using the blockchain to do this. They call it distributed ledger technology. I don't know. And that was the Japan Exchange Group. IBM was involved, Nomura Research, Currency Port, and then industry participants. Okay, so this was a pretty big deal. And it's a very nice paper. That's the title, so you can just download it yourself if you want. Clearing and settlement after trades. Now you might think, well, that's no big deal, right? Actually, think about, if you start reading about it, or if you're familiar with it in other ways, in the US it takes 3 days to clear stock trades. They're working on reducing it to 2 days. And they view that as very expensive and very difficult. I mean, and same day, oh, forget it. That would just be so costly, it's by no means worth doing.
How about the tariffs? Right now, I think that most of the exchange actually is done, at least is official by government, right? In the future, the terrorists can have that terrorist network of terrorists, bit chain, block switch chain. They don't need to, and the government cannot actually mean, right? Like in terms of the transaction?
Well, there's an issue about how much government involvement and how regulation enters into all of this, which I think is your question, right?
Yeah. That's not a big.
There's a tendency, obviously, you know, when you start talking about, do I dare? When you start talking about IBM Japan, for example, or Nomura, they're not exactly trying to undermine the regulation of financial markets.
So for example, ISS want to transfer funds from one place to another place. Right now, they probably have to go through some money laundering process. Right? In the future, they can use.
Well, that's more useful for Bitcoin.
Yeah.
Bitcoin can be used for a lot of things. And so you can use it for money laundering under some circumstances, yeah. But we're not really talking about that kind of application here. Here we're talking about you want to trade shares in Samsung with somebody else. And then you want to clear and settle it. And the issue is, can blockchain be helpful in that regard? Can it lower the costs? Actually, I think, you know, the more you start reading about it, the more I think that one way it actually helps is, part of what's going on is JP Morgan has one database that it uses to keep track of things. Merrill Lynch has another one. They're not compatible. They can't even talk to each other, is from what I can tell, reading. This is a single database. And so everybody's using the same thing. And that could actually lower costs all by itself. And actually, apparently, it takes a fair amount of manual effort for clearing and settling. Never having been involved in this on a personal basis, you know, I find it almost hard to believe. But too many people say it's true. To say, no, I don't believe it. So Manelli and Alistair Milne estimated $40 billion a year worldwide goes into clearing and settling. So that's a big number, and if you could reduce it by half, it'd be 20 billion, so you could save 20 billion. And you can invest a fair amount to save $20 billion a year. It's not like a cap. So the idea is to use a blockchain, all right? Now this is different. It's still, to some degree, a peer-to-peer network, but it's permission. See, the thing is with Bitcoin, anybody who wants to can participate. Anybody who wants to can mine. Anyone who wants to and solves the problem can add a block. The blockchain, for example, that the Japanese exchange group was talking about, and all of the ones that I'm aware of that industry consortiums have put together, is the only people who get to add blocks are people who are invited to do so. People that we trust. All right, so I don't get to, because I'm not JP Morgan. They use a different consensus algorithm. That is, solving this numerical problem actually uses a lot of physical resources. It uses a lot of electricity. And rather than doing that, what they rely on is a consensus algorithm called practical Byzantine fault tolerance. What does that mean? It basically means when we agree on a state, then that's the state. And so if 2/3 of the nodes that are part of the group for agreeing agree on what the state is, what transactions are actually occurring, then that's the state. And then the message setup is set up in such a way that it will, in fact, converge to agreement. See, basically the issue that arises is, it's not the issue, but an issue that arises is, maybe somebody at one of the investment banks is gone off and executing rogue trades, or they want to mess with everybody else. And so this is a way you can ignore what it is they're trying to do, as long as they're n-1 of a third. Just epsilon less than a third. So this is a different algorithm altogether, because it doesn't involve all this mining and everything else. Now an advantage of doing that is like with Bitcoin, a block is added every 10 minutes. That's way too long for financial markets, or even banks or anybody else. All right. So you don't need all this electricity spent trying to solve a problem. The way you solve it is we have a permissioned blockchain. That is, we let certain people in, we don't let it, and nobody else gets in. So what goes on in Bitcoin is called proof of work, and there's no proof of work. Basically, the way they set it up in their trial is the exchange. It is the Japanese exchange group, all right? You gotta be kind of aware of the incentives that are operating here a little bit, I think, but maybe not. No. Is the Japanese exchange basically sends the message about what trades occurred. All right, so that's centralized. And you have to trust them. The trial isn't whether you can keep track of the trades that way. The trial is for clearing and settlement, and whether you can do that significantly faster and significantly cheaper than the way it's done now. And that's what they were trying to see. That's what the trial was all about. They used something called smart contracts, which is a word I haven't really used so far, other than to mention it as a possible application of blockchain. Basically, you can put together contracts, I'll give you an example later, that execute on the block. I don't want to phrase it that way. It can be executed through the blockchain. There's an issue that arises, which I mentioned actually earlier, which is people don't want their positions to be broadcast to other people. You know, I mean, this is a big issue in financial markets, of course. So how do you prevent that? Basically, the way they prevented it is that you can look at your transactions, but you can't look at other people's. They're basically obscured using cryptography. And the issue really isn't, remember, the issue isn't really we want to create a record of everybody who owns IBM, and we want to know who they are and everything else, because people don't want that known. They don't want that broadcast, as a matter of fact. This is creating a record to clear and settle, and to do it quickly and cheaply. Settlement means payment in exchange, and it's done. Mm-hmm.
Now, when you say this is done on the blockchain, are you referring to the Bitcoin blockchain?
No, it's done on their own blockchain.
Permission.
I'm sorry.
So it's a blockchain.
Yes, a blockchain. For the purposes of their trial, it is the blockchain in the sense the only blockchain that matters is the blockchain for their trial. But it doesn't interconnect to any other blockchain anywhere else in the entire universe. Because it's a database, remember? And so I can create my own database. You can create your own database. So the NYSE can have their database, you know, NASDAQ can have their database, whoever wants to have, whatever exchange wants to can have their own. And these are all separate. They're records of transactions on my exchange, your exchange, their exchange. Mm-hmm.
So, isn't the point of a blockchain that you have a trustless system where you can interact with parties that you don't necessarily need to trust? If you have isolated blockchains on individual exchanges where parties technically do trust each other, what's the point? How do you interoperate between?
Well, it's very different. You're definitely correct. It's very different than Bitcoin. That is, one of the advantages of the Bitcoin blockchain is it's permissionless. Anybody can add who wants to. You don't have to trust other people in any way, shape, or form. You don't have to trust anyone. All right? These blockchains are different in the sense they're, you know, and some people think they're a betrayal of the underlying philosophy or idea, but they're permission. That is, you're not allowed to participate unless we trust you. And so they're not trustless, is the word that's used for the Bitcoin blockchain, because it's trustless. You don't have to trust anyone. Here, you decide who you trust, and you're going to interact with them, and you're not going to interact with people you don't trust.
Does the blockchain effectively, does it only effectively transfer or record the transferring of the shares, or is it also recording the transferring of the money? And if it's not recording the transferring of the money, then what happens if it's not settled, and how do you get the shares back? Or
yeah, basically, the way these smart contracts work is the following. That is, the first thing that would be recorded in the, let's call it the JPX blockchain, just to make it clear it's a different one. The first thing that would be recorded in the JPX blockchain would be that you and I have agreed that I'm going to buy some shares. And we tie them up so that you can't sell them to someone else. All right? Now, that's the first thing that's recorded. Now, what's also recorded there is that I'm going to pay for them, and I'm going to pay so many yen for them. And then what happens is there's a second entry. This clears it in the sense that you transfer the shares to me, because I haven't had them up till now. And you indicate, and I indicate that I've transferred the yen to you. And so that I've paid.
So the
That's
shares aren't
my-
finalized until the payment is agreed.
Yeah,
That's
no,
great.
yeah, and they didn't literally do that in terms of this trial, but you clearly could.
Now, in the JPX trial, are they transferring, is this basically, do they do netting first, like we do in most settlement systems, or
No.
is it on a trade-by-trade basis?
Now, one of the issues actually about this is it's real-time gross settlement,
Can't be bilateral.
which some people don't like. Well, they don't. And I'm just agnostic about real-time gross settlement, not knowing anymore.
From the supervision perspective, by design, it is impossible for regulators to see the transactions on the positions.
Oh, no, the regulators could have complete access to the entire JPX blockchain. All they have to have is the keys that the individual agents are using. And so they can have access to the entire thing if the regulations allowed that and they wanted it. So you can't, as long as it's done through an entity like JPX, then it's going to be reasonably consistent. They're going to be consistent with the regulations because they don't want to get in trouble with the regulator.
So if we buy shares or Bitcoin from one exchange, can that be sold through another exchange? Because the different exchange has different information, different data.
Yeah, that's a good question. A good question would be, the question is, what about interoperability of different exchanges? So that I buy, say, IBM shares in London, and I want to, this is an extreme version of what you're saying, but I buy IBM shares in London and I want to sell them in New York. You know, if they have different blockchains, London Exchange has one, NYSE has another, how do I get that to work? That's an issue. And it's not, I'm not saying, it's by no means unsolvable. I'm sure it's not very hard to solve, actually. But you'd have to solve it.
And who are these miners? I mean, how
Who are what?
the miners, how are they compensated? What works?
Well, this GPX trial, there are no minors. There are no minors. No, that's all gone. But basically, what we do is we have certain nodes that we say they're the ones who create approval. The way they did it in this trial actually is that all of the financial institutions, basically investment banks, when they agreed that a transfer, 2/3 of them agreed that a transfer occurred, it was agreed that it had occurred. And then when they agreed that it was settled, then it was settled. All right? And so there's no minors because there's no participation by other people. The only people who can participate, the way they set it up actually is you had the exchange up here, you had the investment banks and the broker dealers, and then you had companies. The only agents who decided whether something had occurred or not were the broker dealers, investment banks. And it was just, they agreed. They didn't have to do anything like mining, so they didn't have to be compensated for mining.
Correct me if I'm wrong. Bitcoin, specifically for Bitcoin, the miners are compensated for their computing effort, right?
Correct.
And in that case, I can understand why the price of Bitcoin fluctuates too much because
Sure.
There must be some arbitrage activity going on, right? What I mean is, if the price of Bitcoin.
How about if we talk about this afterwards?
Can we move on?
Because we're really talking about something different. Okay? We can talk about that afterwards. Because this is really, I think it's, yeah. So, the JPX blockchain is used to set up proof of ownership. But it's coming through a trusted third party. Basically, the exchange is guaranteeing that the trade actually was intended to be made, and then it's finalized through the blockchain. So it's basically taking care of settlement. So what were their overall conclusions? They could do tens of hundreds of transactions per second. If you think about the NYC, that's really teeny. It's a very small subset. So it's not really feasible for current high-volume trading on exchanges, at least the way they implemented it. Now, that doesn't mean it couldn't be implemented other ways. It doesn't mean you couldn't implement it with multiple computers. You could have parallel processing. There are lots of things you can do, all right? So it's just in the context of what they did. It's feasible for post-trade processing, where millisecond and microsecond speeds are not necessary, all right? And they are for some, but not for all. And so like for over-the-counter trades, for example, for things like IPOs, NASDAQ actually has something called LINQ, L-I-N-Q, where what they're trying to do is introduce IPOs on their own blockchain. And so basically their setup was with a central administrator, and they found that it was lower cost than the current settlement procedure. All right, so in that sense, it was positive, the conclusion. Because the idea is to lower the cost, all right? It doesn't get you some of the stuff you get with Bitcoin. It's trustless and other things like that. And this came up already. It's real-time gross settlement. All right, so there's no netting that's going on here.
You could do netting. I mean, there's nothing stopping you from
No, you could do netting. I mean, if you do netting, though, you have to wait a certain period of time so you have stuff to net. Whereas here, you can basically do it almost instantly. Very, very quickly. And that's why you end up with real-time gross settlement. I mean, you could do the reverse and just say, well, we'll do it at the end of the day, and we're just going to do netting.
Or net every 10 minutes or every
Right, or net every 10 minutes even. Yeah. And it would probably prevent a lot of superfluous transfers. I mean, because real-time gross settlement has its own costs, actually. There's a reason why bankers back in the 1850s got together in clearinghouses and netted. So it can also be used as a property registry. Obviously not the JPX blockchain, but a different blockchain. But you could set up a property registry, for example, in Egypt, of ownership of property and transfers of properties in Egypt on the blockchain, and keep track of all the transactions there. That might sound trivial, but if you've read stuff by Hernando de Soto, what you know is, in much of the world, it is not easy to establish ownership of property. There are lots of reasons for it, but getting ownership of the place you live is not a trivial thing in a lot of parts of the world, in the sense that in the US you take it for granted. And so blockchains might be an inexpensive way of solving this problem, because you just need a computer to keep track of all these transactions. Mm-hmm.
But what if the title is still unclear? So if nobody knows who owns this piece of dirt.
No. You have to settle who owns it first.
Yeah.
I mean, that's part of what De Soto does, is actually what he wants to say is basically, what you have in a lot of cases is, it's not a piece of dirt. What you have in a lot of cases is here's this house. It's on a piece of land. Everybody recognizes that it's your property. All your neighbors, everybody else recognizes that. It's not recorded anywhere. Legally, you don't own it. In a lot of cases, it's, the way he puts it actually in his first book is that what happens is a bunch of people get together. In Peru, this happens. A bunch of people get together and they say, we're gonna take over this area. It's called, He calls it government wasteland. All right, so it's land that's owned by the government. They're not doing anything with it. We don't have any place to live. So we're all gonna get together and we're gonna invade. Why are we gonna get together? Well, because if I do it by myself, the police will come along and hit me over the head. If we all do it together, they're less likely to do that. And so people then move in. First of all, they have tents. Then they save up money and they start to build walls and they do all kinds of other things. And so establishing that it's yours is not really actually the big issue. The big issue actually at the moment is having a record so that you can sell it to someone else. He thinks it's really important so that you can mortgage it. I'm not so sure mortgages are so hot, but
So we know which accounts are our accounts, but that's kind of confidential. People can't tell from the account who owns it, right?
it's not really confidential, it's really the following. It's a matter of legal ownership. It's a matter of, it's so hard to think about it in the context of the US, because we have almost everything has clear legal ownership. Whereas in a lot of foreign countries, you don't have clear legal ownership of your house. It's not that you don't know that you know what your house is. All your neighbors recognize which house is your house. It's that there's no government registry. The government says, we own it. And your improvements don't belong there. We can bulldoze them over anytime we want, okay? I don't want to get too much in this, but it's just a possible application that goes well beyond financial markets. And DeSoto is actually working on it. Smart contracts are an issue, or something that can be executed. I thought of this because we bought a house about a year ago. And we went through a couple of transactions before we finally settled on the house we had, that we bought. And so you have the whole escrow set up in the US, and the way it works in the US is I write a check to the broker deposits in his account. If the deal falls through, then eventually he gives me my money back. All right, that's basically the way it works. It doesn't have to work that way. You could use a blockchain actually to execute the whole thing. Not that everybody's going to use Bitcoin or anything, but you could use blockchains to solve all of this in what are called smart contracts. That is, the first part of the smart contract, just like with a trade of security, says, okay, $1,000 of my money is tied up in this transaction with the real estate broker, 2 real estate brokers. And then how does the transaction get executed? The way it gets executed is later on, there's a transaction with everybody signing it. The first one, 3 people sign it, me and the 2 real estate agents. And the second one, it says, okay, either all 3 of us, if you want to think of it the simplest way, agree, I get my money back. And so it's not encumbered anymore. And so there's no transfer across banks. This might sound like not a big deal, but if you're engaged in, have a couple of house deals fall through, it can take like 2.5 weeks before some real estate agent sends you your money back, creep. And this would get rid of all of that. I'm not saying this is a great application that's going to change the world, but I'm using it to illustrate smart contracts. That is that you have basically, here we're going to, just like with the clearing and settling, here we have an agreement to do something, here we've done it. And the ownership gets transferred. People have thought of more complicated contracts. And I think this is where Craig actually starts to get excited, is people are talking about doing swaps on a blockchain instead of doing them through central clearinghouses. And that sort of riled him up. So people are talking about doing in Europe, for example, contracts for differences you could easily do. These things are data dependent. There's sort of an idea that the blockchain would sit there and poll an outside source for data, and then when something happened, then it executes the transfer through the code that's in the blockchain right then. All right? So no intervention by people. When I talked about the escrow thing, there's intervention by the real estate agents and other people. Here, it just executes on its own. Pre-written computer logic code, it's stored on the blockchain and it executes. People have also come up with the idea of what are called decentralized autonomous agents. What does that mean? it's hard to get a handle on it, you know. Bitcoin's been interpreted as a decentralized autonomous organization. That is, that it's an organization that does various things, and it does it through a blockchain. Another version of this, though, this is a computer called M5 from a Star Trek episode in the second year, actually. This computer was given control of the Enterprise, which was the starship in Star Trek. And then it promptly started shooting all the other starships. Because it doesn't really matter why, but it mercilessly attacked it, the other ones. And so this idea of decentralized autonomous organizations is basically, well, instead of having a corporation with a board of directors and everything else, I have a bunch of computer code. And this computer code says, in the event of X, we're going to do Y. In the event of X1, we're going to do something else. In the event of X3, we're going to do something else. And here are all the rules for what we're going to do. You know, sort of like the longest chain, except we have a lot more rules than that. And then they execute if those things happen. All right? I don't know. It seems to me there's lots of problems with that. If you've written very many computer programs, one of the problems with that actually is, well, the computer will do, I always tell students this, the computer will do what you tell it to do. It will not do what you meant to do. It doesn't know what you meant to do. It knows what you told it to do. They're really stupid. And so in this case, well, if you tell it to defend itself, it's going to just mercilessly attack friendly ships, because that's what you told it to do. So I think that's a little bit stretching it. So the key things to take away from this are blockchains are databases. In and of itself, that's not tremendously exciting, not tremendously different. It's a ledger of transactions, as a matter of fact. But what's different about them is rather than having a central party who does everything, and there's one copy of the database, there's multiple copies of the database. But then there are rules to reach consensus where everybody agrees on what the current state is. All right, now some of this starts to sound amorphous and a little, I call it airy-fairy, you know, just a little bit not clear entirely what's going on, but it's really all very concrete. Like I said with this Japan trial, or for that matter with Bitcoin. One of the big issues is reaching consensus, which is called the Byzantine generals problem. And it doesn't have to be the way it is in Bitcoin, which involves a lot of effort. That is, Bitcoin is different than a lot of what people are talking about for financial institutions because it's permissionless. Anybody can participate who wants to, and if you want to have that, then you have to have clear mechanisms in place to stop malicious agents. And it's a big issue. On the other hand, if it's permissioned and only other investment banks can participate, then you can trust them to do certain things at least on a regular basis, or at least most of the time. There are privacy issues that arise, and these have to be dealt with. And like in the JPX trial they did. There are lots of possible applications, right? So that, in that sense, I think it's very exciting. Clearing and settlement between banks, financial firms. There's no particular reason why it takes 3 days to settle a stock trade. To be honest, there's no particular reason why I have to pay Wells Fargo $75 when a university in Europe insists on sending me a paper check in euros. You know, that's a ridiculous, and it takes them a couple of months. We're not talking about, oh, it takes them a couple of days. No, a couple of months. Because of all the clearing it has to go through. It has to go through multiple agents all along the way. And these blockchains have the potential of making that occur virtually instantaneously. Equity and debt issuance, like I said, property records, smart contracts, maybe distributed autonomous organizations. So let's think about it in terms of research issues. A friend of mine asked me, well, so what are you going to say about that? In part, look, this is a technology. It's not in place. And so if you think about it in terms of empirical papers, it's not obvious what you do, to me anyway. On the other hand, there are really serious policy questions. One of the issues that comes up all the time in this literature is that it's going to disintermediate a lot of institutions. Maybe so. Obviously, the Japan Exchange Group hopes not, but could be. I mean, you can definitely do a lot of trades on exchanges, and you don't necessarily need brokers to do it. And so there are lots of possibilities here, and there are possibilities in terms of regulation. You know, it's like Craig, part of what he relies on is with the central clearinghouses is the regulators won't let people do it. On the other hand, you can do things regulators don't let you do. Big investment banks can't, but somebody like me can. There are theoretical questions, I think, for sure, about organization around a blockchain, the joint ventures that are created, the incentives that are created by an organization like that. You know, because there are issues that arise. People have different incentives in terms of the operation of the organization and what the implications are. Bitcoin, actually, there's more obvious stuff like evasion of capital controls. Is a big thing, I think, in terms of Bitcoin and remittances. All right, so that's that. Thank you.